Okay, and the next question, what they're doing is they're asking us a geometry question. Let's see how this works. Remember, we do it bit by bit, and we fill in on our diagram what we've read. In the diagram below, O is the center of the circle. We say thank you so much. Another center given. With O at the center, it would mean these two lines are radii that are equal. In fact, those three are radii. If there was a point indicated there, we would have also identified that one as a possible line of interest for us. But we've got three radii. Okay? Having those two radii in this triangle here will make this little angle there equal to that, because those angles lie opposite equal sides. Angle Q3 is equal to angle A2, and they are not equal to these angles even though those sides are equal. Please don't make that silly mistake. Okay, we have a line that goes through the center of the circle. If the moment we read that this is a chord or a diameter, we're going to come back and talk about that angle, but we are not 100% certain that AB is a chord, or that BP is a line segment or a secant. We'll have to read that. Okay, so they told us the center of the circle. Now we can also go ahead and we can say the angle at the center is twice the angle on the circumference. So if we label these as Y, that angle there is going to be 2Y. And if we label those angles up there as X, look at it from this way. The angle at the center is the angle BOQ, is equal to twice the angle on the circumference, which is X. So that angle will be 2x. Follow my fingers again. There's QB. There's the angle at the center, is twice the angle on the circumference. Okay, so this whole angle here, I must find a way to indicate that. I'm going to do that. That whole angle is indeed 2x, if that is x. Now I've introduced the x, I'm going to put it there, and I'm going to put the y over there. Angle at the center is twice the angle on the circumference. We haven't read anything else that is significant yet. We'll have to come back if we read those things. Okay, let's read on. RQ and RB are tangents at points Q and at point B. At point Q, RQ is a tangent, RB is a tangent. Okay, that will make these two lines equal to one another, which will make the angle there, I'm going to do it with two lines going through it, is equal to the angle over here. Those two angles are equal. Why are they equal? Because the two tangents to the circle are equal to each other. Because they equal, these are the angles that lie opposite the equal tangents. Okay, but more important now, let's go back. We have RB as a tangent, we've got OB as a radius, so that angle is 90 degrees. The radius runs perpendicular to the tangent. There's OQ, a radius, goes perpendicular to the tangent, so that collection there is a right angle. The radius is perpendicular to the tangent at the point of tangency. That makes me very glad, because now we've got quite a few things that are equal to one another here in this diagram. Okay, I can, if I want to call this another variable. I see I called that little one here a y, so I must not think that this angle is y. Let's do that. Make sure we don't confuse ourselves. Okay, that comes from the idea of those two tangents and the radii. There's more. There's the angle between the tangent and the chord. Now let's see. Let's go with this angle, this tangent first. There's the chord. The chord is BQ, is equal to the angle in the alternate segment, which we've already labeled x. So look carefully what's going to happen now. This angle is equal to this one. Look again. There's the chord, there's the angle in the alternate segment. So this angle is also x, which makes it a two-liner. So these two are two-liners, and I'm going to do that so that I have the same symbol representing all these angles. The angle here, in other words, there is equal to the angle in the alternate segment. I've already established that this is equal to that. So this angle here, the full angle, is also x, which makes this full angle, sorry, those two were equal, that was x, so this became x, those two are equal, so this is also an x in terms of the angle. Okay, that came from the tan chord theorem. I have another angle here between the tangent and the chord, which is also equal to the angle in the alternate segment. So those are all related to one another. There are no other chords, but look at this. Beautiful. If I read that RP is indeed a secant or something which will make that a straight object, then there's another angle Q4 I can consider that will be equal to the angle down here, which is B1. But I've got to wait until I read it. Let's read on. Diameter AB is produced and meets RQ produced at P. Okay, so BA is produced, meets at P. It meets RQ produced. There's a word missing here. The word produced is missing at P, because we don't know if this is indeed a straight object without having the word produced there. And I'm sure that was the intention. So we can take this as straight, we can take that as straight. So BP is a line segment, and so is RP. Okay, I'm going to make a notice of that. So this one here, Q4, is indeed equal to B1, which makes Q4 one of those angles with a one line in it, and makes it equal to Y. This diagram is really becoming very, very full. Okay, let's have a look. What else we can say? I don't think there's much more. Let's read on. QA, where's Q? And where's A? Is over there. QB, and QO are drawn. QO are drawn, and so is RO drawn. Okay, so those are just lines that they connected angles with. Prove now that RBOQ is a cyclic quadrilateral. RBOQ is a cyclic quad. So we've got to prove two things. I think the way we're going to prove this, it's for 3 marks, it shouldn't take much, is to prove that this angle here, the one I'm coloring in green, now remember the green angle consists of x plus y, is equal to this green angle here. That's what we want to prove. So we want to prove that this is x plus y. Okay, let's see if we can do that, and how we can do that for 3 marks. Okay, we know that Q1 plus Q2 here is 90 degrees. We've learned that, so that must be 90. Q1, where's my Q1? Here's Q1 plus Q2 is 90. Okay, so we can do it in 2 ways. We can work with an exterior angle. We know that this combination there is 90, and that combination is 90. I think that's going to be quicker for us to do. So let's work with that. Angle Q1 plus Q2. Just zoom out here. Q1 plus Q2 is 90 degrees. Why did that happen? OQ was perpendicular to RQ. What was the reason there? The radius perpendicular to tangent. So it all started with the tangent given. And the same here, with OB being perpendicular to BR. Radius perpendicular to tangent. What happened there? was B1 plus B2 was 90 degrees. Therefore, angle RQO plus angle RBO is 180 degrees. But RQO and RBO are opposite angles of the quadrilateral BROQ. Okay, so we're saying those two are 90, but they're opposite angles of that quad. So therefore, RBOQ is a cyclic quadrilateral. Why? The opposite angles were supplementary, became supplementary. Okay, folks, so that was the easiest way to go and do that one. We could have tried to prove that this was x plus y. I think we would have had a bit of a problem trying to get that done quite quickly. Okay, so R2 now. R2 we must prove is half the size of O3. R2 is half the size of O3. Now we've had that O3, we made that 2y, so we just need to prove actually that R2 is also a y, which we know it is. Where did it come from? Well, twice this angle. So we're going to start that is twice this, but these two are equal because of the fact that those are radii. Those two are equal angles in the same segment, so this is definitely a half of that. Let's quickly do that for 5 marks. Angle O3 is twice angle B2. Angle at center equals twice angle on the circumference. Okay, and let me zoom out a bit more. Okay, so we're going to let B1 be y. Let angle B2 equal y. We're just doing it so we don't have to carry on with angles beyond this. So we say, but OQ is equal to OB radii, which makes angle Q2 equal to angle B2 equal to y. Those are angles opposite equal sides. So what do we have so far? We've got this twice that size, but we have that now equal to that because of the sides that were equal, and we can also say that Q2 is also equal to R2, which makes it equal to y. Angles in the same segment. Why? Because this was a cyclic quadrilateral. So therefore, indeed, remember, R2 is equal to B2, but B2 is half of O3. So we can now argue that the angle R2 will equal a half of the angle, not Q, but O3. Okay, through this whole relationship that happened here, I'm going to show you how I connect it again. R2 is connected to Q2. Q2 is connected to B2, and B2 is directly connected to O3. How's it connected? Well, from here, B2 is equal to a half of O3. I keep on writing Q, it's O. Sorry, folks. Half of O3. B2 is equal to Q2. Q2 is equal to R2, because R2 then becomes equal to B2. R2 is a half of Q3. Okay, remember to always spend a lot of time filling in your diagram. Once your diagram, all the relationships are there, you can go back and look for things that are equal for these things that we're asking the questions about. Okay, I hope that helped you, folks. that you understand this better.